Hey class. Okay, I feel kind of stupid. I'm just going to finish up this last problem. This is sort of obvious, but I did get the right answer. I just forgot that this is c squared. So c is equal to the square root of 206, which as soon as I stopped recording, I realized. And so that is about 14.4. We'll just put it like that. So that's a much more reasonable number, by the way, given that triangle that I was looking at. So, okay. So here's the next question I want to ask you. When would you use the law of cosines and when would you use the law of sines? So let's look at this again. I'm just going to get a new page. Law of cosines. It says c squared equals a squared plus b squared minus 2ab cosine of c. So what you can tell here is you have an enclosed angle. So anytime you get a triangle, if they give you two sides, oh, sorry, I'm going to make this red so you can tell. If they give you two sides and this angle between them, then law of cosines is going to be really useful because you have two sides and the angle between them. So you know all of those things. So that's a good time to use law of cosines. Another great time to use law of cosines is if you have all three sides and you don't know any angles, because then you can use, in this case, you're going to use C, A, and B, and you can solve for that last C. Okay, but if somebody gives you a triangle, let's say they give you this triangle, and they give you an angle here, we're using red for what's given. If they give you this angle and a side across, and then they want anything else, then your law of sines might be more useful. Remember, law of sines says that sine of c over c equals sine of b over b equals sine of a over a. I don't know why I did that backwards, but anyway. So if you know these opposite ones, then you're probably going to go for this one for just simpler math. And if you know, again, enclosed ones, then go for this law. All right. So given that, let's go do an example problem. So here's one that's just straight out of Khan Academy. Puma Grove, the world's best female golfer, is 2 shots away from winning another tournament. From a marker exactly 200 meters from the pin, the angle between the pin and the ball is 110 degrees as shown. By the way, I know nothing about golf, so I'm like, what in the world does pin mean? So luckily they gave us a picture. From the ball, Puma checks the angle between the marker and the pin, calculates, then swings. Her ball travels 234 meters directly to the pin. What was the measure of the angle between the marker and the pin? So now I'm just going to look at this picture, okay? And luckily, they give us all that we need to know. So we have this crazy triangle, and we want to know this angle between the marker and the pin, right? So they're telling us which angle they want, but what they have given us is two sides, and you'll notice we do not have this enclosed angle. We don't have this. We have this one. So I want you to think about this. Whoops, I'm going to just drop my pen. I'm going to erase that. So if you think about this just a little bit, you'll say, well, I just told you when to use which law. I'm going to move this over just a little bit. Oh, I can't do that. Okay, so we have an angle here, the 110 degrees, and we know the opposite. We want this one, and we know its opposite. So this is totally set up perfectly to use the law of sines. So let's just say sine of A over A is equal to sine of B over B. And as long as they're, the opposite ones, we don't even care which one is called A and which one is called B and which one is called C. So we're just going to say that the sine of 110 degrees over 234 meters, because that's the opposite one, is equal to the sine of theta, which is, I'm just going to call this theta, the angle we want to know, over the distance opposite from that one, which is 200 meters. All right, so sine theta is equal to 200 over 234. Our meters cancel out, times the sine of 110 degrees. And I will just do that on my calculator and hopefully not get confused like last time. 234 divided by, and then we'll do that. So I'm getting that sine theta is equal to 0.803. I wouldn't normally round right now, by the way. I would just do this on your calculator. But so now you want the inverse sine. Actually, I'll write it this way, sorry. I'll take the inverse sine. So theta is equal to the inverse sine of 0.803. Make sure you're in degrees if that's what you want your answer in. And I get 53 degrees. All right. So that seems reasonable given my picture. And I feel like, there's always it's always a good idea to sort of look at if your answer is reasonable and makes sense. And in this case, it does. So that's an example of how you solve these problems.